Here are solutions to homework set number 6 for 376 Embedded Systems. This homework set looks at A to D conversions and a chi-square test. The first problem is to set up your PIC processor to work as a temperature sensor. So here, this is the thermistor that I'm using. If I set up a voltage divider, so the circuit's actually 5 volts, going through a 1K resistor to my thermistor, going to ground. I'll measure this voltage with the PIC processor. What that voltage tells me is the resistance. Once I know the resistance, I know the temperature. So that code is 7,000 bytes, 3,500 lines of assembly. The main routine, this part that really matters, I'll turn on the analog input. I'll repeat over and over again, read the analog input, convert to voltage, convert to resistance, convert to Celsius, and then display. So here's what that looks like. The first number is the raw A to D reading. The second one is the volts, resistance in ohms, and temperature in Celsius. So this is the temperature in my room. My room reads 2.08 volts, 719 ohms, or the number I really care about, 32.34 degrees Celsius. It's a nice warm sunny day, so it's about 76 degrees Fahrenheit in my room. I measure the temperature of the drinking water. So here's a cup of cold water from the drinking fountain. Let it cool down. Oops. The temperature sensor just fell off. The temperature of the drinking fountain. See it cooling down. It's about 21 degrees Celsius. It's a pretty warm water for a drinking fountain. If I measure my hot tea, which is no longer hot because it's been sitting around in the office all day, my hot tea is currently, I just lost my sensor to my hot tea. Hold on. Okay, trying that again. There's now a temperature sensor at the bottom of my teacup. My hot tea is reading 34 degrees Celsius. I have a temperature sensor. So that's the first part. The next problem is a chi-square test. So here I have a die programmed in the PIC processor. What happens is it waits for me to hit a button. Once I press it, it waits until I release it. And while I'm pressing it, I count really fast, mod 6. Once I release it, whatever the count is, plus 1, is my die roll. So if I try that, I press release. On release, there's my die. Rolled 1, 6, 3, 2, 4. Is that a fair die? Well, to do that, I roll the dice a whole bunch of times and then do a chi-square test. To do that, I take the expected frequency, I roll the dice 94 times, so here's how many times I should get a 1, 2, 3, 4, 5, and 6. Here's how many times I actually got a 1, 2, 3, 4, 5, 6. Find the chi-squared score. There you take the difference squared divided by 15, difference squared divided by 15, difference squared divided by 15, add them all up. That's my chi-squared value. To convert that to a probability, use a chi-squared table. Or here I use StatTrak. The StatTrak, I've got 6 bins, meaning 5 degrees of freedom. There's my chi-squared score. Probability is 0.9, so there's a 90% chance that this is not a fair die. Actually, it is a fair die. I just got unlucky. Problem 4. Suppose it really is a loaded die. So here I'm going to count mod 13. That means the number 0 appears 3 times. The number 1 through 6 appear just 2 times in the sequence. So I'm getting too many zeros. Can I spot that using a chi-square test? So again, the approach is to collect some data. I download the code, roll the dice, see if I'm getting too many zeros, which plus 1 becomes 1s. If I'm getting too many 1s, do a chi-square test. So here I expect 26.83 for each number, uniform distribution. Here's how many I actually got. Take the difference squared, divided by 26, difference squared, divided by 26, add them all up. Use a chi-square table to convert that to a probability, and I wind up with 39%. So when I ran it, the loaded die was actually more fair than the fair die. That's just chance. With only 150 die rolls, that's not enough to spot a loading of 1 in 13. If I had the source code, I could tell, but if I just look at the results, it's really hard to spot. I need more data. That's a chi-square test. Finally, the last problem. Last problem is to program a roulette wheel. So here's kind of what it looks like. At the start of the game, I press the die, or press the button. This starts the wheel. This is the number I'm betting on. I'm going to bet on number 3. So I bet on number 3. It spins the wheel and comes up with a winning number. Let's try the number 2, or number 1. So if I bet on a number, like here I'm going to bet on the number 3. It rolls the die, spins it, and wind up with a winning number of 7. If I get the wrong number, I lose $1. Let's bet on the number 6. It spins the wheel, winning number was 0, I lost $1. Bet on the number 0. Came with the number 1. So that's the idea, kind of simulate a roulette wheel. What it's supposed to do is when I hit the number, it actually generates the number 0 through 8, 9 numbers. If I get the number 0 through 7, it's a legit game. On number 8 is whatever number I bet on, minus 1. It then rolls the dice, spins the wheel. When it stops, if I get the right number, I win $8, otherwise lose. So here's the flowchart for it. I'm going to initialize with a bank of 100. Wait for me to bet. Let's hit the number over here. I'll generate the winning number, spin the wheel, and when it lands, stops, it'll calculate my winnings. See, we actually got the right number. I won $8. The code, one way to do that is when I hit a button, this is checking all of port B. If no buttons are pushed, keep checking. If I did hit a button, check which button I pushed. That's the number I bet on. Count mod 9. When I release, whatever the number is, whatever n is, that's the winning number. So if it's less than 9, it's a fair game. If it is equal to 9, then it's going to be whatever I bet minus 1. I'll display on the LCD. Here's what I bet. Spin the wheel. When it stops, I'll check if I landed on the right number. I win, otherwise I lose. So bet on the number 3. There's the wheel spinning. Came up with a 2. Just close, just missed. Bet on the number 2. 2, I win. It's more fun if you have a little beeper going beep, 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 and slow it down at the end. But that's extra coding I didn't do. Okay, so once you have that, I'd like to find out, is my program working? That's kind of what I did. If I bet on the number, it stores the number that I bet on. It gives me $8 when I win, lose $1 when I lose. Seems to work. The hard part, is this a fair game? Can I detect that some numbers come up more often than not, or that the odds of winning are actually 1 in 9? A couple ways of doing that. Here, I played the game a bunch of times. Here's the number I bet on. Here's the winning number. I won 3 times in 46 games. To check, I should win 1/8 of the time, should lose 7/8. I actually won 3 games, lost 43. What I should do is in 43 games, I should win 5.75, lose that many, find the chi-squared score. Take the difference squared, divide by 5.75, difference squared, divide by 40, add them all up, get 1.5. Do a chi-squared test with only 1 bin, or 2 bins, meaning 1 degree freedom, chi-squared score of 1.5, probability 77%. So I'm 77% sure this is a loaded die, that I do not have a 1 in 8 chance of winning. It's actually pretty hard to tell. You have to play a lot of games to find out you're getting cheated, and by that time, you're probably broke. That is homework set number 6 for 376 Embedded Systems.